All right, while he's getting started here, it's a great pleasure to be here at Technion. The first I heard of Technion, I was probably about 26 years old. I was a product manager for an EMC product called the Orion solid-state disk, and I was working alongside of the head of engineering, who was 12 years my senior, was Moshe Yanai. So I know he's a well-known person here. That was my first introduction to Israeli innovation. And it went on through my career. As it was stated, I ran mergers and acquisitions, and in 2006, in addition to acquiring RSA, we had acquired three Israeli companies, including Kasha, which has become a very big part of our software portfolio today at EMC. So that's been quite rewarding to see that turn into such a great product. So as he said, I joined RSA 5 years ago. It was quite a shift to move from the storage side of things to security, but it's been a great experience. We have a wonderful development team here in Israel, in Herzliya. We have about 400 employees at RSA and over 1,000 employees at EMC. So we are very, very well entrenched in here. And I'm here to talk today about the transformations that we're seeing in security today. Information security, that is, and the implications on how security is going to have to evolve as we think about how it's going to be thought of and implemented. And we're seeing a fundamental change now in how security actually works. External trends such as mobility, the consumerization of IT, and big data are radically expanding the attack surface, and that must be defended, and transforming how information technology is built, delivered, and used. The implications for security are far-reaching. Ensuring trust in today's digital world is demanding more than some new tools or technologies are capable of. It also requires a rethinking of some of the basic concepts that have driven information security for decades. I'll talk about the underlying trends in security and share with you what we believe is the path forward of what we call intelligence-driven security, which is based on big data platforms, taking into account the volume, the variability, and the velocity of data itself. We believe in this approach, and we believe that it can help defend information and infrastructures even in our hyper-connected and digital, borderless digital worlds. So when we talk about the expansion of the attack surface, the logical place to start with is the digital information itself. And EMC has done a tremendous amount of research on the growth of information, but whether it's financial data, intellectual property, or other sensitive information, it's usually the target of cyber attacks. We picked 2007 to start off with in this graph because that's really when the first iPhones were delivered and introduced. So it sort of marks an early point in today's mobile, media-oriented smartphone world and the consumerization of IT. As you can see from the growth chart here, that the digital information continues to accelerate at an astounding pace, with more and more of it coming from unstructured forms, created outside, yet the enterprise is expected to manage all of it. This data represents huge value for the consumers and enterprises, but also represents a more attractive target than ever for our adversaries. And imagine having to separate the sensitive information from the non-sensitive information at scales 30 times what we're doing today. The transformation of applications also changes the attack surface. In 2007, we were seeing enterprises with just usually a handful of web-facing applications, a website and maybe a customer support portal. Today we're seeing there's an app for that, with huge proliferation of small apps that often come in a matter of a short period of time, that can easily be built by non-IT professionals to access sensitive information. By 2020, we'll see connecting these apps to more and more of our big data systems. Why? Because by doing so, we'll be able to enrich our user experience, market more effectively, and deliver new kinds of value. We're also creating even more connection points between applications, data, and the internet. The sheer number of devices is exploding as well, as we all know. Today's enterprise manage thousands, maybe even tens of thousands of devices. Consumer-facing sites such as e-commerce will be accessed by millions of devices. But by 2020, we'll have connected as many as 20 billion devices to the internet, instrumenting everything from cars to our home appliances, even medical devices such as pacemakers. The explosion in the number of people, devices, and web services on the internet has everyone thinking about the implications of IPv6. As you know, this next generation internet protocol will provide more than 340 trillion addresses and will connect to billions of people with a huge range of devices that are not connected today. The growth of this Internet of Things does not represent a new level of complexity. Does not just represent. We believe there will truly be destructive attacks using digital means are not likely today, but by 2020, we'll see them become a reality. As adversaries begin to target transportation systems and communication networks in more ways than we can imagine today. Airlines, for example, are excited by the capturing all the telemetry for their airplanes to analyze fuel costs and weather patterns, reliability curves, and so on and so forth. But think about the implications that all these flying computers will have and the digital risks that it will create. And our willingness to expose personal information adds to this risk as well. Targeted spearfishing is a problem today, clearly. We were a target at RSA ourselves a couple of years ago. But criminals and nation states will continue to mine our social world, leveraging their big data skills. They'll have more complete profiles of individuals and will be able to use the data in more creative ways than ever. And even though we may express concern and willingness of the social media sites to collect and monetize our personal information, the trends clearly show that we'll willingly trade this information for convenience and economic value, basically resulting in the end of privacy as we think of it today. It's a competition between two goals. The more companies and organizations on one side trust and know about us, the better they can serve us, but it can lower the cost. But on the other side, the other side is our adversaries will know more about us, and more targeted their attacks will be. One of the most fundamental changes occurring is how IT itself is designed and delivered. Only a few years ago, most IT infrastructures were walled cities, fixed perimeters that were easily defended, with only a few access points to the outside world and connections with a few highly trusted partners. Today, we're in a hyper-connected world where more and more information and applications are connected to partners, customers, suppliers, contractors, and others. These connections speed up business, lower the costs, and simplify communication. However, they create more and more points of risk and potential compromise. As we move to this increasingly mobile, consumerized world, a cloud-based world, the problem gets magnified. With BYOD, IT teams don't always get to choose what devices that connect to their systems, but they are chartered with the responsibility to ensuring the security of those connections. It's a near impossible task for IT and security teams today. All these factors have given our adversaries new points to attack, and new kinds of adversaries have emerged as well. Today's enterprises need to defend themselves against nation states, cyber criminals, hacktivists, each of whom have different motives and a means at their disposal. We're also seeing an evolution of these sophisticated intrusion types of attacks. Think advanced persistent threats to and also DDoS attacks now heavily targeting financial institutions globally. Traditional approaches to security are not just designed to be effective in this world today. These technologies were developed in a world where defending the fixed perimeter and malware and spam was their primary goal. They were also designed at a time when threats were slower to evolve and easier to detect. AV tools depend on malware signatures, for example, worked when the viruses evolved over the course of months. Today, malware evolves daily, being recompiled and morphed to evade detection. And of course, advanced threats avoid detection entirely by walking into the network in the guise of a trusted user or device. Also, security tools were developed in silos. Each new threat or point of exposure created the need for a new type of point security product, adding cost and complexity to today's environments. Today's attacks traverse the network to identify weak spots and valuable assets. Our security tools defend one element of the infrastructure, but cannot work together to defend against these fast-moving, agile types of attacks. This new model that we call intelligence-driven security is based on entirely different attributes. It must be based on risk as its core principle and able to assess risk in a real-time basis. IT systems and users' access demand evolves constantly. Fixed views of risk hard-coded into systems are obsolete as soon as they're deployed. Risk must be determined by people, looking at supply chains, information flows, and users. But they also must be able to be determined by security tools themselves, so that security can be married with user convenience and business agility. Security must be dynamic and agile. Security systems today must be able to detect and defend against threats and tactics that have never been seen before. Adversaries are creative and change tactics constantly. Security systems must be able to spot those faint signals and slight abnormalities that often are the only signs of a potential compromise in the enterprise. Finally, we must be able to understand context. External threat data and information from the network has to be immediately available to ensure rapid response to the potential threats. While the pressure to transform security is clearly real, there's also some real impediments to change. Budget inertia is one of those impediments. Not only have security tools been oriented towards these perimeter-oriented defenses, but budgets and processes have as well. Today, the bulk of the budget is spent on prevention, trying to stop the threats at the gate, so to speak. But increasingly, customers are rethinking that approach. They're lowering the percentage of the budget that they're spending on these perimeter security approaches, such as anti-malware and firewalls. And they're rotating the remaining budget towards tools and tactics that enable them to defend inside the network. Today, it's inevitable that adversaries are going to be successful in penetrating the network. Any sophisticated security professional understands that. What they're trying to do, though, is decrease what some practitioners are now calling the dwell time. There's other challenges as well. New skills and processes are needed. Today, there's a global shortage of security professionals with the expertise to be able to identify and defend against this range of adversaries and risks faced by most organizations. We believe that cloud and SaaS-based applications, security applications, will be able to help these security professionals address their needs. Information sharing is another gap. Our adversaries are very good at sharing information, tactics, and tools. The next generation security products we're seeing in the market today also need to mature. They need to become more automated and easier to deploy. And as we take a look at the evolution of customers, I talk to customers often about this curve. Many of them are still stuck in this control phase, the perimeter static phase. Many of them have moved that are in regulated industries to the compliance phase, better than the first, but clearly not security-oriented. A lot of them are now starting to take a look at IT risk and moving into this and moving up the stack. And then ultimately, their goal is to get to enterprise risk and understanding that. At RSA, we're following these trends closely, and we're looking to reshape our business as these threats and attacks are growing as well. Massive amounts of data and the ability to analyze it quickly is becoming key to how we're defending our customers. We call this, as I said, intelligence-driven security. It's security that's based on situational awareness, automated risk assessment, and real-time detection. This is how we believe all companies should be taking a look at their security systems. In order to address the opportunity, organizations need to focus on this intelligence-driven security solutions that leverage far richer data sets. We think there's 5 key components to intelligence-driven security. The first one is it needs to be it needs to leverage risk intelligence, the ability to compile a holistic view of risk, not just through IT, but the entire business. Second, it needs to have advanced analytics. Third, it needs to have adaptive controls. Fourth, integrating the technologies across the stack. And fifth, finally, is sharing threat intelligence across the community. Identity is one area that we're working with to address this challenge. It's not just about securing a connection to a VPN anymore. It's about ensuring trusted interactions between people, applications, and data across a variety of networks and devices. In intelligence-driven security, we need to apply big data analytics to measuring risk throughout this chain. If the risk is too high, we can apply adaptive controls that can request better credentials, ratchet back access, entitlements, and potentially even trigger an investigation. How can we architect this? Through big data. By being able to move beyond 1, 2, or 3 factors, and by using nearly any aspect of behavior or characteristics, we can create much finer risk scoring and more human-like means of ensuring trust. And we can do this in ways that still preserve user convenience, which is crucial to our consumer-driven IT standards today. Now let's turn our attention to security analytics. The tools and security teams will use to identify and mitigate advanced threats inside the enterprise. The key is to start with a platform that ingests much wider sets of data sources, not just logs and events, but all network traffic, configuration information, data classification, and such, all indexed in a manner that's optimized for security investigations. Fraud prevention is another area. We have a large team right here in our Herzliya Development Center, one of the foremost anti-fraud groups globally. These organizations depend on online properties such as e-commerce and banking are getting hit hard and being targeted through this area. Data analytics is key to this solution. Behavior of criminals is different than that of customers. Almost by definition, for them to succeed, they have to take actions that are different from the regular users. Analytics that can create rich profiles of normal customer behavior, and processing that compares current users to those profiles, and they can spot suspicious behavior quickly enough to stop fraud or other malicious behaviors on e-commerce platforms. Risk and governance is another area. Managing enterprise risk with the appropriate governance framework is critical in security today. You need to know the status of your controls and ensure the thresholds you set are not broken. So finally, in summary, transformation of infrastructure, business, and threats make traditional security less relevant. A new approach must be based on risk and context. It must be able to respond to known threats and unknown threats so that security does not fall behind the pace of business innovation or threaten innovation itself. And finally, big data holds the key. It's the engine for our intelligence-driven security approach that meets these needs and can enable enterprises to leverage the value of mobility, cloud computing, data analytics, while managing the potential risks that come with the new advances in technology, business, or society. Thank you very much.